Okay. Exponential. You can just zoom out so that so that we can capture these two. Exponential and reciprocal. So these two should be able to combine them. Reciprocal graph. Okay. The idea is to be able to identify the graph. If you see a quadratic graph, can you identify it now? Talk to me, class.
Yes.
What will it look like? A parabola. What about cubic? Can you identify cubic?
Yes.
So what do you notice about cubic?
It has
Two what?
two turning points.
Two
Two turning points.
turning points. Another name for turning point is?
Minimum point.
Nope.
Curve.
Another name for turning point is? I didn't say the type of turning point. What is another name for turning point? Turning point could be maximum or minimum, I know, but what's another name for turning point? When you climb stationary point. So there are two stationary points normally, right? But in some cases, we don't have stationary point. Remember I told you you can have this too, right? So it's like the two stationary points already meet somewhere, safely. So it doesn't have to be this all the time. It could be like this, such that this and this are coming close together. Am I making sense? So you can have this too, okay? So it's either you have this shape or you have this shape for a cubic function, okay? So parabola like this or like this. Cubic like that. So we want to see what exponential function will look like. That's why I'm giving you that to plot. So if you look at number 2, go to number 2, plot this one. After you plot that, go to number 2. You see it says draw the graph of from -4 to 4, right? Right?
Yes.
So in your calculator, you put x is equal to -4. Whatever answer you get, you locate the point. There's no need to draw the table. Do you understand that? You get the value of y for -4, you locate the point on the graph immediately. You get the value of y for -3, you locate the point immediately. For 0, 1, 2, 3, up to where?
4.
Up to 4. Okay, so do that for number 2 and 3. Use your calculator to get these values. Alright? Then you're going to notice something about the shape of an exponential function. This is not necessary. Okay? What I'm trying to say is you can put in your calculator, you need 2 raised to power something, right? 2 raised to power, open bracket, you need 2, otherwise just -2 on it like this. 0.25. So which means you should label this as, no, actually -4 is the first one. That's like -0.6, which is like 0.1 basically. So this is your -4, -3, -2, no, this is your 0. You can go back. I don't know if 2, 2 will work. 1, 2, 3. You can't have 2, 2. So maybe 1, 1. Yeah. So 0, this will be -1, -2, -3, -4, 1, 2, 3, 4, like that. So once you have this, label the y's. also. Maybe another 1, 2, 3, 4, whatever. Okay. Then for each one, minus 3, minus 4. What is the value of y? You locate the point. Minus 3, you locate the point. You don't have to draw the table. It's a waste of time. You can put the answer somewhere just to maybe remember what to plot if you wish. But the table is not necessary. Yeah, that's the shape, John. Check the other one as well. If you don't have enough on the y-axis, it's fine. I think you have enough. Okay. Because you need 16, right? So there's enough. Why did you stop here? But it says from minus 4 to 4. Why did you do minus 3 to 3? You follow the instruction. You don't do what you wish. Follow the instruction. I know it's not enough space. You have to, no. The cut does not go like that. No, that's not possible. That's not possible. There's no way this is bigger than this one. It actually increases. And don't go minus 4 to 4 like that. Okay, so minus 3, what is that? Okay, check minus 3. What is minus 3? Yeah, but that's bigger than 0.06. Oh. Quickly. If you have questions, please ask me or ask someone beside you.
John.
You don't have to scream, sir. John is right beside you.
Video copy. Decision copy. Calculator is always hard. They put it 81. They put it anywhere that 81 can be shown. 10, 20, 50. Super, you can put it on there. Just draw like 10, 20, 30. That's what I told you.
So once you are done, I'll sketch a shape. I don't want to put it yet. So we're going to do question 6 together. So you will be able to do questions 4 and 5 yourself. Okay, everyone stop. What do you notice about the graph of exponential function?
Go on.
It goes up, right? But then it goes up like sharply. It increases, within a very short time. Do you notice that?
Yeah.
Like the difference between 1 and 2 may not be much in terms of y, but between maybe 3 and 4 is so much. Take for example the graph of maybe 3 raised to power x. When x is, please pay attention. I didn't ask you to open your book. When x is 0, what do you get? 1. So if this is my xy axis, when x is 0, I get 1. When x is 1, now look at it. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, for example. When x is 0, I get 1. When x is 1, when x is 2, when x is 3. Now, when x is 1, I get what? 3. Look at the gap is just 2, right? The space is 1 here, the space is 2 here. I increase x by 1 unit from 0 to 1, and the y increase from 1 to 3. The space is 2. Okay, that's not so bad. Now, let's increase by 1 again. When x is 2, what is y?
9.
This is 3, 4, 5, 6, 7, 8, 9. Can you see this jump? I increased just by 1. And it has increased from 3 to 9. Space of 6. If I increase by 1 more, it will jump to where? 27. From 9 to 27, that's space of 18. So the exponential, I said virus, jumps within a space of little time. Have you seen the graph of the infection rate of the virus? You will notice this. This is how the government of that country knows that, oh my God, there is trouble. It's like, oh, yesterday it was here. Today it's here, which means, oh my God, so many people have been infected within 24 hours. That's alarming rates. That's how you know there's trouble. Do you understand that? Also, we learned exponential growth and decay before. This is what the graph will look like. That's how you know it's an exponential growth. Because it's going to start very small, and within a very short time, it jumps up. And it continues to jump up at that rate within very short intervals. Understand? So this is what an exponential graph will look like. So you should know. So now we have 3 functions that you know. When I'm giving you a test next time, I'm going to ask you to identify them. Parabola represents what? This represents what? Now you have exponential. Understand? So let's look at this. So now I will sketch it here. Of course, for your level, we only care about when a is greater than 0. When a is less than 0, we do that with the IB students. The difference is that it's going to flip. So a greater than 0, you have this, right? So you have this. Okay? When a is less than 0, it's just a mirror image. This is the mirror line. You don't need to worry about that now. Because whatever the value is the negative on the y-axis that is the result, right? Look at it. This is 1. This is 3. This is 9. This is 3 raised to power x. If I put minus here, when I put 0, it will work this out and put negative, right? So that will be minus 1, minus 3, minus 9. Do you understand that? So it's going to be a mirror image. And the x-axis is the mirror line. But that's not for IGCSE. I'm just keeping in the information. That's something that we do in IB class. Of course, they investigated themselves. If A becomes big, maybe when this is 2, or when this is 20, they know what must happen. It's part of the IB stuff. But of course, you don't need to memorize, because you'll be taught through investigation. You're going to discover this yourself when the time comes, so don't need to worry. But for now, just remember, this is what it is. Okay? All right. The question says, the sketch shows the curve, the graph of this, shows a curve with this equation. Again, what you are practicing so far is this. What I'm trying to tell you is maybe 2 times this. That's what you can see here. Can I ask a question? This is equal to 6 raised to power x, yes or no?
Yes.
Yes. Kiana? Chop? James? Killy? No? You? No? Or you don't know?
No.
It's not. You? Okay, some people say no, some people say yes. Now I don't know what to follow anymore. You guys are confusing me. Can't you just agree?
No.
Just say yes, so we can move on. Who's with me? Yes. Oh no, I'm alone. Okay, William is with me. At least I have a friend. I have a friend in William. Thank you, Mr. William. It's not. Okay? Can somebody tell us why it's not? Yes.
Big math.
Say that again?
Big math.
Big
So
mass.
we do indices first and then multiplication.
Exactly. But this one means that we do multiplication first, right? Before the power. But according to big mass, it's actually power first before the multiplication. Somebody might argue that even if you use big mass, it's still the same thing. What other way can you use to justify that they are not the same? Yes, Jubino. No. I just need to explain this, not example. Anyone else? Yes.
It's just like we play X over random down.
That's the example he's talking about. I want us to speak in general. Yes, let's all.
Just solve the two sides of the equation and then compare pairs.
Say that again?
Like solve both sides of the equation and then compare pairs.
We can't solve both sides because the 6 raised to power x on its own cannot be solved. It's not an equation. Unless I'm not getting what your intention is, but the construct is not proper. Yes, sir. I will explain after James. Yes.
Is it because like a b x is like the whole equation by the power, but that one's only 3 by power?
Repeat that. That might be what I'm looking for.
It's like when you put
AB
power, it means like a b bracket
like this.
Yeah. But when you put like the thing, it's only b that is power.
That is it. I get what he's saying, and I think he has communicated most of the information. There's a difference between this and this. That's the difference. In this case, only b has the power. And that is what this curve is about, which is the same as this. Only x3 has the power x. But here, both of them have the power. So this is like 2 times 3 in the bracket before you raise it to power x. That's this one. So they are not the same. Am I making sense? Let's see the difference. 2 times 3 all raised to power x and 2 times 3 raised to power x. When x is 1, this is 6 raised to power x. This is 6 raised to power 1. Do you agree? And this is going to be 2 times 3 raised to power 1. This is 6 and this is 6. Oh, maybe you are right. Maybe. Let's see. Now, when x is 2, this is going to be 2 times 3 raised to power 2, which is 6 squared, which is 36. But this will be 2 times 3 squared. Big mass. Power first. 18. Are they the same? No. So they are not. Okay? The graph of 3 raised to power x will be different from the graph of 6 raised to power x. And it's not the same as 2 times 3 raised to power x. Understood? So we need to be very careful. Just wanted to chip in that. Thank you everyone who contributed to that. Now, let us move on to our main question so we can move on with our lives. Now, it says the curve passes through 2 points. How can that help us? Anyone? What does it mean for a point, for a curve to pass through a point? Mathematically, how can you interpret that? We have done it before. Yes. What does it mean that 290, the curve passes through 290? What is the implication of that? Quickly. Yes, Lasson.
There is a solution of that.
It means it's a solution. A round of applause, please. A round of applause, please. We talked about that in the past. And what does that mean? That is a solution. That's the next question now. 290 is a solution. Solution of what, by the way?
Of the equation.
Which equation?
Of the curve.
Which equation of the curve? Anyone? Yes, Enya. Y equals ABX. That's what you should say completely. It means 290 is a solution of this equation. Now, what does that mean? Sit up properly. Yes, Mr. William. Yes, sir.
It's a valid point.
It's a valid point. Point on the curve, you mean?
Yes.
Yes, but that's okay. I think let me put it this way. You are giving me your answer from the geometric point of view. And that's right. If there's a solution, it means it's a point on the curve. That's absolutely right. Now let's go algebraically now. If we are working something out, what is the implication of that point being a solution or of that point being on the curve? Algebraically now, not from geometric point of view. Yes, sir?
90 equals 8 times b.
It means when you substitute a and x and y, it will be a valid equation. You can substitute x and y. Hello? It means it satisfies the equation. Remember, I think that was the word we used. It means that point satisfies the equation. What does it mean to satisfy? It means when you put x and y into this equation, left and right side will be equal. You remember that? We talked about that a few weeks ago. So, it means this point will satisfy this equation, this point will also satisfy this equation. Can somebody guess the kind of problem we are going to end up running into? After we substitute, yes sir? Simultaneous equation. Why do you say that? Who can tell us why will it be a simultaneous equation? You need to think ahead. Come on, you need to think ahead. Why did it say that? Why would this lead to simultaneous equation? Anyone? Anyone apart from Enya? Yes, James? Not really. It has nothing to do with power. It has something to do with something you need to think about. Yes, Tomasz, then I come to you.
2 points.
2 points. And not just because you have 2 points.
2 equations.
There's only one equation there. But you meant something and I don't want to, lead you on. So that's why I'm not going to say something beyond that. There is something you meant to say. Well, there will be 2 equations. So, there are 2 unknowns. What are the 2 unknowns? A and B. Okay? There will be 2 equations and 2 unknowns. Do you understand that? The 2 equations will be from here and from here. So, let's use the first one. Using 2,90 in y equals ab to power x. Are you paying attention? Your y is 90, right? And ab raised to power 2. Am I making sense? This will be your equation 1. Again, using, what's the other one? 4, 8, 10. In the same equation, what does that give you? 8, 10, yes? Power 4. These are the 2 equations to be solved. But none of these look like the simultaneous equation we have done, right? It doesn't look like 2 linear equations. It doesn't look like quadratic. These are simultaneous exponential equations. Uh-oh, Mr. Daniel, you never taught us this one. So it's not our fault that we cannot do it. I know that's what you're thinking. Yes, it's not your fault. But can somebody guess what we should do? How to solve this kind of equation you will learn in Form 5 under geometric sequence. So if you know what we're about to do now, it will be easier when somebody teaches you geometric sequence in Form 5. Yes, Nathaniel?
Can we make A the subject?
That's a good idea. I'm not going to do that. Okay, let's do this. Make A the subject. So for the first one, Nathaniel, A will be equal to what? Tomasz, can we see this part? Just to be sure. Okay. Yes, A will be what from here?
Square root.
Square root. You said make A the subject.
Oh, sorry, 90
90 over
B squared.
B squared. Then from the second one, A is equal to?
810 over B to the power 4.
Okay, so we make A the subject. What do we do next? This is a good step. Like, you don't know anything about this, but this is a reasonable step. Very sensible. Jovino.
You cancel out the power to make 90 over b squared into 30 over b.
Why?
That doesn't serve.
Why? 30 squared over b squared, 30 over b all squared, why? There has to be a reason for whatever you want to do. Yes? If this is now equation 3, and this is equation 4. Yes? How does this help? Yes, Tomasz?
Add equation 3 to 4.
Say that again.
You add equation 3 to 4.
Add equation 3 to 4. So you have 2a, then you have 90 over b squared plus 810 over b raised to power 4. I think you just make our life worse.
No, I mean like put 9t over b squared and put it instead of a in the second.
So tell me what to write, because when you say add, that's my understanding of add.
So 9t over b squared equals 810 over b to the power 4.
Can somebody tell me what it should have said?
Substitute
Substitute.
A for
Maybe substitute equation 3 into equation 4, or equate equation 3 and 4, not add. Add means you had the left, you right, the right. Yes, this is a way out. We don't have